Welcome back to Backspace Academy. In this lecture, we'll have a look at the compute and networking services of AWS. We'll then have a look at some examples, and finally, we'll finish up with a hands-on lab where we're going to deploy a WordPress web server using the Amazon EC2 service. Amazon Elastic Compute Cloud, or EC2 for short, provides virtual servers in the AWS cloud. You can launch one or thousands of instances simultaneously and only pay for what you use. There's a broad range of instance types with varying compute and memory capabilities, and those will be optimized for different use cases. Amazon EC2 autoscaling allows you to dynamically scale your Amazon EC2 capacity up or down automatically according to conditions that you define. It can scale up or down by launching or terminating instances based on demand. It can also perform health checks on those instances and replace them when they become unhealthy. Amazon Lightsail, it's the easiest way to launch virtual servers running applications in the AWS cloud. AWS will provision everything you need, including DNS management and storage, to get you up and running as quickly as possible. Amazon Elastic Container Service, or ECS for short, is a highly scalable, high-performance container management service for Docker containers. The containers, they will run on a managed cluster of EC2 instances. AWS Lambda is a serverless service and lets you run code in the AWS cloud without having to worry about provisioning or managing that service. You just upload your code and AWS takes care of everything for you. So let's have a look at how we could use these services to deploy a web server in the AWS cloud. Here we have the AWS cloud and our virtual private cloud, or VPC, located inside that. And remember, a VPC is our own private space within the AWS cloud, and no one can enter that unless we allow them to enter it. We can launch an EC2 instance, and that can be running our web application, for example, WordPress. So what happens if this single EC2 instance becomes overwhelmed by demand? For example, we might have released a new product and our WordPress application cannot deliver the web pages quickly enough to satisfy that. What we could do is that we could tear down that instance and put in a bigger instance that could handle that demand. And that is called vertical scaling. And that used to be all the rage 10, 20 years ago. But the problem is that it takes time to do that. And while we're doing that, our application is not running. And also, what happens when the demand goes back down again? Do we have to tear that down and then put in a smaller instance? And what happens if that happens every day? What happens if that happens every hour? It's just not going to be economical for us to do that. What we can do is that we can horizontally scale, and we do that by adding more instances. And as demand goes up, we add more instances, and as demand goes down, we terminate those instances. And that way, we still have continuity of our application. Our application will always be running because there's always going to be at least one EC2 instance to look after the demand. One problem with this architecture is that it has multiple endpoints for our web server. And that's not practical because customers are not going to go to one endpoint until that stops working and then go to another one and then another one. It's just not going to work like that. And obviously their bookmarks in their browser are not going to be valid. So we need a way of having one single endpoint for that web application that our customer can go to, and then having a way of distributing those requests to a EC2 instance that is available. That is where elastic load balancing comes in. So it can receive traffic from our end users, and it will distribute that traffic to an EC2 instance that is available. So a request will come in, it will distribute it to an available EC2 instance. Another request will come in and it will distribute it to a different EC2 instance that is available, and it will balance the load across those EC2 instances. And if one of those EC2 instances become unhealthy, it will fail a health check with the elastic load balancer. And then the elastic load balancer will no longer send traffic to that unhealthy EC2 instance. But what happens if that demand is only for a short period of time, for example, half an hour? What do we do then? It's not going to be practical for us to terminate instances when demand goes down and then launch instances manually when that occurs. We can't do that every hour. It's not going to be practical. And that's where the auto scaling service comes in. It can launch EC2 instances automatically when the demand on those instances increases, and it can terminate automatically EC2 instances when the demand on those instances goes down. It can also perform health checks on those instances, and if one of those instances becomes unhealthy for whatever reason, it can replace that instance with a healthy instance, and it will do that automatically without you having to do anything at all. So now we'll have a look at the networking and content delivery services. Amazon CloudFront is a global content delivery network, or CDN for short, that securely delivers your frequently requested content to over 100 edge locations across the globe. And by doing this, it achieves low latency and high transfer speeds for your end users. It also provides protection against DDoS attacks. Amazon Virtual Private Cloud, or VPC for short, lets you provision a logically isolated section of the AWS cloud. And you can launch AWS resources in that virtual network that you yourself define. And this is your own personal private space within the AWS cloud, and no one can enter it unless you allow them to enter it. AWS Direct Connect is a high-speed, dedicated network connection to AWS. Enterprises can use it to establish a private connection to the AWS cloud in situations where a standard internet connection won't be adequate. AWS Elastic Load Balancing, or ELB for short, automatically distributes incoming traffic for your application across multiple EC2 instances and also in multiple availability zones. So if one availability zone goes down, the traffic will still go to the other availability zone, and your application will continue to deliver responses to requests. It also allows you to achieve high availability and fault tolerance by distributing traffic evenly amongst those instances, and it can also bypass unhealthy instances. Amazon Route 53 is a highly available and scalable domain name system, or DNS for short, and it can handle direct traffic for your domain name and direct that traffic to your back-end web server. Amazon API Gateway is a fully managed service that makes it easy for developers to create and deploy secure application programming interfaces, or APIs, at any scale. It handles all of the tasks involved in accepting and processing up to hundreds of thousands of concurrent API calls. It's a serverless service, and as such, you don't need to worry about the underlying infrastructure. AWS looks after everything for you. So let's have a look at an example of how we can use these networking services of AWS. So here we've got the architecture that we looked at before in the compute section, but one thing we didn't mention was availability zones. So let's just say that we've launched that architecture in a single availability zone. What happens if that availability zone goes down? What happens to our traffic? Our traffic has nowhere to go, and our application stops delivering responses to requests. That is why it's always desirable to have our architecture distributed across multiple availability zones. That way, if one availability zone goes down, the other one will continue to operate and the infrastructure within that other availability zone will continue to respond to requests. We can launch EC2 instances in multiple availability zones, and our elastic load balancing service can distribute that traffic across multiple availability zones as well. So if one availability zone goes down, the elastic load balancer will continue to distribute traffic to the availability zone that is still healthy and to those instances in that availability zone that are still healthy as well. So let's just say our application running on these EC2 instances is a WordPress web server, and that contains lots of images and lots of video that is static content. It's not really changing that much, and it's not efficient for us to continue to keep delivering that from our EC2 instances. We would like somewhere to put that where it can be delivered with high speed and low latency and to take the load off our EC2 instances. That is where the CloudFront Content Delivery Network, or CDN, comes in. So we can get these large images and large videos that are not really changing that often, and we can put that in a CloudFront distribution. And CloudFront will cache that and distribute that across hundreds of edge locations across the globe. So when your end user requests that video or those images, it will be delivered to them with really high speed and low latency. And at the same time, it's going to take the load off your EC2 instances and is going to significantly reduce your costs. At the same time, dynamic content that is changing regularly, CloudFront can forward those requests over to the elastic load balancer, which will then forward them to an EC2 instance. So that way you have the best of both worlds. You have dynamic content delivered as a dynamic content, and at the same time, you have these large videos and images that aren't really changing that often, delivered very rapidly. Now that CloudFront service or that CloudFront distribution will have its own DNS name that we can put into a browser and we can directly access that. The problem with that is that that DNS name for that CloudFront distribution will be something very complicated and just won't mean anything to our end user at all. So we would prefer to have our end user type in a domain name and have the requests for that domain name forwarded to that CloudFront service. As you can see here, we've got example.com, and that is where Route 53 domain name service can come in. So Route 53 will grab those requests for your domain, example.com, and it will forward those requests over to the CloudFront service, and the CloudFront service will handle it from then on. So let's just say we work for a large enterprise that has its own corporate data center. And the reason it's got its own corporate data center is because that is located where the employees work. And we don't want our employees to be slowed down by a network. We want them to be able to work efficiently. But at the same time, we have resources on the AWS cloud that those employees also need to access. So we need some way of having a high-speed connection between our corporate data center and the AWS cloud. And that is where the AWS Direct Connect service comes in. And that can provide a very high-speed fiber optic network between our corporate data center and the AWS cloud. And that is completely private. Okay, so that's a very complicated architecture, and don't be too concerned if that's very overwhelming, because if you're going on to become a cloud practitioner, you're not going to need to really be able to produce this yourself. As an associate level certification, that is a different story. You'd be expected to create this yourself. But cloud practitioner, you'll need to know what these services do. You'll need to know that Route 53 will forward requests for your domain name to a back-end endpoint. CloudFront will distribute your content to hundreds of edge locations across the globe. Elastic Load Balancer will receive requests and distribute those requests to multiple instances across multiple availability zones. A virtual private cloud is your private space within the AWS cloud. The AWS Direct Connect is a high-speed fiber optic network connection between an on-premises corporate data center and the AWS cloud. If you understand that, then you're well on your way to passing the Cloud Practitioner exam. Okay, so coming up next, we're going to have a lab. So make sure that you download the Introduction to AWS lab notes that come with this course. So what we're going to do is that we're going to launch an EC2 instance, and we're going to select an Amazon machine image of a WordPress web server. And that will allow us to deploy a WordPress server on the AWS cloud. And then we're going to be able to go to our browser and view our website that was created by that EC2 instance. And we're going to do that all through the AWS Management Console on our desktop computer.
Okay, so in the AWS Management Console, we go to Services, we go into Compute Services, and we select EC2. Now that will take us into the EC2 dashboard. If you've never used EC2 before, you might be presented with a welcome screen, but just go to Instances on the menu here and click on Instances. And we're going to launch an instance. Now we first need to select an Amazon machine image or an AMI. And that is a template that contains the software configuration, the operating system, application server, and applications that are required to launch an EC2 instance. We can select an AMI provided by AWS from the AWS user community or from the AWS marketplace. Or we could also select our own AMI if we've created an AMI previously, which we obviously haven't. So we're going to go into the AWS marketplace and we're going to search for a WordPress AMI. So they're the WordPress powered by Bitnami. That will be fine for us to use, so we'll select that one. And we're going to select the T2 micro instance because it is free tier eligible, which means that if we create this instance and then we shut it down afterwards, we're not going to get billed because it's on the free tier. We have a whole heap of other options that we can do, but we're just going to go into the configured instance details, and the only thing that we need to change here is to auto assign a public IP. So we need to have a public IP address for this EC2 instance so that it can have a presence on the internet and so that we can access it through a web browser. Now, there are a whole heap of other options that we can look at, but this is really just an introduction to AWS. We're going to do something very simple and the most simple thing that we can do right now. We're not going to get into discussing any of this stuff because we're going to go into quite in-depth detail on the EC2 service and VPC and a whole heap of other stuff further through the course. So for now, we're just going to click on Review and Launch and accept everything that we've got there. And we just click on Launch. And instead of choosing a key pair, we're going to proceed without a key pair. And a key pair is used to connect directly into our EC2 server. And we're not going to be doing that, so we're not going to be connecting into the Linux operating system, but normally you would, and normally you would download a key pair and you would use that to connect into your Linux server. But for now, we're not going to do that. And we just acknowledge that we will not be able to connect to this instance because we don't have a key pair. And we launch the instance. So after a certain amount of time, it will go through its process and will be returned to the EC2 dashboard. And there we go. So we just click on View Instances. and our instance will come up with a status of pending. Okay, so after a few minutes, our EC2 instance status or its instance state has changed to running. And that means that we should be able to see our web server on the internet. So if we've selected this instance and we look at the details for this instance, so we go down here and we can see that it has been assigned a public IP address. So when we're configuring our launch for this, we did select to create a public IP, and that is a public IP address that has been created. So if we go to that, we should be able to see our WordPress application. Okay, and there is our WordPress application, and looks great. So we can't really do much with it now because we need to be able to administer our WordPress application. We need to be able to log into this site and put web pages on it and whatever. So the people at Bitnami, what they've done is that when this EC2 instance launched, they created a username and password and they embedded that in the logs of our EC2 server. So when it was launching, there will be a number of logs that will output information. So we just need to go into those logs. So we'll go back into the EC2 management console. Again, we've selected our EC2 instance. We'll go to Actions. We'll go to Instance Settings. And we're going to get the system log. Okay, so there's the system log. If it first doesn't come up, you just need to give it a bit of time. Just go away, have a cup of coffee, come back, and the system log will be there. It doesn't automatically just come up straight away. Sometimes it does take a bit of a while to come up. So we just scroll down until we find the section where it has our details. So here we can see we're setting the Bitnami application password to that. So we just need to copy that password. So we just copy. And we'll just close out of this. Now, if we go back into our user's blog or into our blog there, and we just go to that IP address again, and we go to admin. And that'll take us to the admin section, and we'll need to put in a username. So the user will be user, and then we just need to paste in that password and log in. Okay, so there you can see, we won't remember that password. So there you can see that we've logged into our administration page of our WordPress application. So we can do whatever we want. We can add some pages in here. We can go into pages, add new page if we want. We can do whatever we want as we would with any WordPress application. So that's how we launch an EC2 instance or an EC2 server to create a web server. Now that we've achieved that and we've created these resources, we're not going to need them anymore. So what we're going to do is we're going to get rid of them. We're going to delete them all and terminate these instances. So what we'll do is go back into the EC2 management console. We'll go into Actions, and then we're going to go to Instant State, and we're going to terminate that instance. And it's just giving us a warning saying that, do you really want to do this? Yes, we do. So yes, terminate. Okay, so after a certain amount of time, and it will take quite a bit of time, that will go from shutting down to terminated. So that's all that we need to do now. So again, there's a lot more to the EC2 service that you need to know. But for now, I think you've got a good idea of how it all works. So it's now your turn to go and grab the lab notes and do it all yourself. And I'll see you in the next one.